The chain rule is for composite functions. Okay, up until this point we have learned the product rule and the quotient rule. The product rule is when we have two expressions that are multiplied together. The quotient rule is when we have two expressions that are divided by one another. But what if we have a situation where there is a composite function, meaning this? What if I said, hey, h is really f of g of x? Okay, this is not f times g, this is f of g. So whatever output you'd get from g, you would plug it in as the input for f. It happens all the time. So what would I do then? Well, the derivative of that, I started writing the wrong letter. Let's start with h prime. H prime would be f prime of g times g prime. So this is the wordy part, but this is how it works. The derivative of the outer function with the inner function intact times the derivative of the outer function, or the inner function, So it is worth noting that this is the inner function and f is the outer function. So I might word it this way. I might say, what's the biggest thing happening? The biggest thing happening is, in this case, cosine, actually 3 times cosine. Or what's the biggest thing happening? Well, e to the something. And that would be the outer function. Well, then the inner function would be the stuff that would eventually turn into the input of the outer function. So let's get started. By the way, as we do this, I'm going to introduce the letter U to you. And it is going to seem a little bizarre and out of context. But later on, when we are about 3 or 4 units down the road, you're going to see it, and the context of that is going to make a little more sense. So noticing that this is obviously not division, quotient rule is out, and it looks like multiplication, but it's not. This is not 3 cosine times 7 pi x. This is the 3 times cosine of 7 pi x. And don't let 3 times make you think that we're going to use the product rule with the 3 and the cosine. You could, but then you run into zeros and it's just not worth the trouble. So let's not. This is going to be a chain, because that's what the lesson is. But it also is because there is a composite function. And the biggest thing happening is somebody got cosigned. Well, not just cosine, they got cosine times 3. So 3 cosine of something. I'm not going to use the letter x. I'm not going to use the variable x. I'm going to use the variable u. And u often stands for a function. U and v are very frequently used in calculus to represent entire functions. Again, this will come in handy later. So if you're like, where did u come from? It's not up here. It's not on the paper. It's not. Don't worry about it. It just represents the input. But the input is actually a function. G is this inner part, which would be 7 pi x. So let's do the same thing we've been doing with product and quotient. And let's find f prime and g prime. The derivative of 3 cosine of u would be, well, negative 3 sine u. And the derivative of 7 pi x, don't complicate things. Don't be like, well, 7 times pi times x, and then we're multiplying this times that. Okay, 7 pi is a constant. 7 times pi is probably like 22 something, 22 point something. It might be 23, I doubt. But it's close. All right, now I'm super curious. I want to find out what 7 pi is. I just need to know. Almost 21. 22, almost 22. Anyway, irrelevant. So constant times 1 is constant, and then subtract 1 from your exponent. So 7 pi. All right, coming over here and using the chain rule. And the chain rule says I need f prime of g, and then I'll multiply by g prime. That means I'm going to take this g, and it's going to be the input right here. And u, the variable u, often represents an entire function. So not always, but in this case, in this context, it represents an entire function. And again, that's going to come in much later and very handy. You'll be glad you met u now. Thanks, you. So, that was not funny at all. We're going to take this and we're going to plug it in there. So we're going to have f prime, which would be negative 3, sine of 7 pi x. And we're going to multiply by g prime. And g prime is 7 pi. Okay, so this is good. It's sort of done, but let's clean it up a little bit because it's kind of gross. So negative 3 times 7 is negative 21 pi sine 7 pi x. Let me tell you what not to do. Don't be like 7 times 7 is 49. No, 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 no. This stuff is being signed. So this stuff is off limits to be simplified with any of the rest of the constants that are multiplied. Okay, number 2. Number 2 is also a chain rule. That's the whole point of this lesson. And the biggest thing happening is e gets raised to a power. So I look at this and I say, man, what's going on here? E is going on, e to some power. And if that doesn't make sense, ask yourself the question, what's the little thing going on? What's the input? Well, the input is this little exponent. It's 9x squared, and g prime would be 18x. And f prime is, this one's easy, e to the u. The derivative of e to the u, in this case, is e to the u. There are exceptions to that, depending on the value of u. But anyway, I'm getting ahead of myself as let's not. Anyway, f prime, you don't have to write this every time. I was going to say the derivative of e to the u is u prime e to the u based on the chain rule, but for what we're doing, e to the u will suffice. So this goes in right there. Sorry, I was trying to be very technical in my language, and I could be confusing if I do that too much. So I'm going to have e to the u. Well, u is this function right here, so 9x squared. So f prime of g, so e to the 9x squared times, and then g prime, so 18x. And this is right, and it's fine, but no one writes it like this. Let's put it in order. Order is where the exponential stuff comes last. There we go.